Hey everybody, today in our math lesson, we are starting a brand new chapter on multiplication with decimals. So we have successfully passed through our multiplication of single digit and multi-digit numbers. And now we're going to move into how can we multiply decimals. And specifically today, we're going to be multiplying decimals by powers of 10. Okay. So when we think about this, our learning target says find products. Remember, products is essentially the answer to a multiplication problem. We're going to find the products involving decimals and powers of 10. Now, our success criteria today says I can explain how to multiply a decimal by a power of 10, and I can explain patterns in the placement of the decimal point when multiplying a decimal by powers of 10. So, for example, let's go ahead and look right here at this exploring growth. So, pause your screen for a second. If you do not have your Big Ideas textbook out, you need to be on page 175 with me. All right, so now that you're ready, let's go ahead and look at our table here. So we're going to use the relationship between positions in a place value chart to find each product. So you can see over here our first expression we're working with, and we know this is an expression because I do not see an equal sign, but I see two factors I'm multiplying together. So I see 2 and 5 tenths times 1. Well, we know that the math property that says the multiplication property of 1 essentially says any number. It could be any number. It could be a whole number. It could be a decimal. It could even be a fraction. If you multiply that by 1, you are going to get the exact same answer, okay? The exact same value. So 2 and 5 tenths times 1 is obviously, like we can see right here, 2 and 5 tenths. Now, when I go 2 and 5 tenths times 10, remember 10 is 10 to the first. That is a power of 10. What I'm going to do is I'm going to see that I have essentially moved myself up the place value chart. And now I have pushed myself up to the left. So my value has increased here. So I can see my decimal would be here, and I obviously have no decimals to the right. Okay. Now, what happens if you think I multiply 2 and 5 tenths times 100, that second power of 10? Well, again, I'm going to move to the left. I'm going to move myself up the place value chart. So instead of moving myself up once, can you guess how many times I'm going to move myself? I'm going to move twice. So I would move myself up the place value chart twice, and I would see that I'm sitting here. Well, Miss Young, what do I put here? There, I can't leave it blank. Well, friends, you put that placeholder 0. And then obviously I can see my decimal would sit here, and I have no decimals to the right. All right, now I want you to look at the bottom. Something's going to be a little bit different here because when I look at these here, I see, okay, I'm multiplying by 1, I'm multiplying by 1/10, and I'm multiplying by 1/100th. Well, when I look at those, what I'm really seeing is that these are just your decimal powers of 10. If I look right up here above me, we know those are whole number powers of 10. Down here, when I move to the decimal side, I have decimal powers of 10. So, friends, let's put 2 and 2 together. If we moved ourselves up the place value chart and increased in value when we multiply by whole number powers of 10, what do you think we're going to do when we multiply by decimal powers of 10? Well, if you guess that we're going to move down the place value chart and our value is going to get smaller, then you are absolutely correct. So I'm going to clear my screen so we can see what we're working with down here. Now make sure you're following along because I just might check when I return. So obviously we can see 2 and 5 tenths times 1. That multiplication property of 1 says you're going to get the exact same value, 2 and 5 tenths. Now, when I move to 2 and 5 tenths times 1/10, that's not a whole number power of 10. That's a decimal power of 10. Well, because it's 1/10, when I look at it this way, remember we can also write it as our fraction form as 1/10. How many times will I move 2 and 5 tenths down the place value chart? Well, if you guessed once, then you are absolutely correct. So, what that means is I'm going to shift all the way down by 1. So, instead of being 2 and 5 tenths, I am now 25 hundredths. Now, we know we don't want to leave this left hand side naked, so we got to put something over. We got to put that placeholder 0. Now, when we look at 2 and 5 tenths times 100th, remember that can also be written like this. Our decimal powers of 10 have that fraction equivalent, okay? So, how many times do you think I'm going to shift down here? Well, I'm going to shift twice. So, instead of being 25 hundredths, or right here at our first level, 2 and 5 tenths, I'm going to become 25,000. Now, don't forget, friend, can we leave this tenths place blank? No, we have to put the placeholder 0, recognizing that we do not have any tenths. Now, here's what I'd like for us to evaluate. Now that you have your tables filled in, take a second to think about what patterns are you noticing from our top chart versus our bottom chart. I want you to take some time to reflect on this. All right, friends, so go ahead and turn your page to the next page so we can look at Think and Grow. After you have reflected on that question, we're going to go ahead and look at Think and Grow. So, our problem that we are solving is 38 hundredths times 10 to the third. Well, we see a whole number power of 10 here. And I notice that I am multiplying a decimal times that whole number power of 10. So let's look at our directions here, our insight. It says use place value concepts. Every time you multiply a number by 10, each digit in the number shifts one position to the left, which we would call up in the place value chart. But notice, I'm multiplying by 10 to the third. So isn't that 1,000? But it's also 10 times 10 times 10. How many times 10s are we doing? 3. Because 10 to the third means that I would multiply 10 times 10 times 10. Okay? So let's evaluate. If I'm starting here, I can see I'm going 38 hundredths times 1. I'm going to get 38 hundredths because multiplication property of 1 tells you so. Okay, now look at this. What if I go 38 hundredths times 10 to the first? Well, we know that 38 hundredths times 10 to the first really is 38 hundredths times 10. Now, friends, let's look at this. Here's a trick. How many zeros does that power of 10 have? 1. So you know how many times you're going to move up the place value chart? 1. But notice what these blue arrows are telling us. What they're saying is not only do you shift up the place value chart, that's one way to describe what's happening, but another way to describe what's happening is that decimal point is moving once to the right, because we should see our value increase. And if I move that decimal point to the right, when I multiply by whole number powers of 10, I'm going to see my value increase. Okay? So here's our rule. Decimal power of 10, decimal moves to the right. No, I'm absolutely wrong, Miss Young. I hope y'all giggled at me because I just made a boo-boo. I just made a, okay? Let me reword. When I multiply any number, any decimal, times a whole number power of 10, my decimal is going to move to the right. So let's take a look at this. Notice what happens here. I started with 38 hundredths and I multiplied by 10. Well, 10 has 1 0, so I move that decimal from here all the way to here, and I'm going to get 3 and 8 tenths. Well, what if I multiply 38 hundredths times 10 to the second? Well, that exponent says 2, and we know that 10 to the second is 100, and I see two zeros. So guess what you're going to do? You're going to move that decimal 2 times to the right. And I got 38. And notice this, friends, where are our values moving? Well, they're increasing. They're moving up that place value chart. Now, what if I go 38 hundredths times 10 to the third? Well, guess what? 10 to the third has an exponent of 3, but that also means that 10 to the third is 1,000, and I see 3 zeros. So pause the video and you try to figure out what your value will be. And if you paused and you figured it out, that means that you're going to move that decimal how many times to the right? 3 times. So I'm going to go 1, 2, 3. But Miss Young, there's a blank spot. I can't have a blank spot. Well, guess what you fill it in with? A 0. So this becomes 380. All right. Give me a big thumbs up, even though I can't see it right into the camera. If you got 380, bingo, bingo. Okay. Now, here's what I'd like for you to do. I'd like for you to now look at this example because, friends, something switches up here. I want you to notice this. Up here, I was multiplying by whole number powers of 10. Of course, my products got bigger because when you multiply by whole numbers, you get larger. Well, friends, look down here. What do? Because I'm now multiplying by decimal powers of 10. Well, friends, when you multiply by decimals, a decimal times a decimal, you know what actually happens here? You're going to see that when you multiply by decimal powers of 10, your product actually ends up smaller. So it's kind of like what happened up there with the whole numbers is the exact opposite when I work with the decimal powers of 10. So that kind of helps us out here. We're seeing those opposites. So let's look at our example here. I'm multiplying 9 and 2/10 times, what does this one? Say it out. Oh, yeah, it's 100th. Well, that means I'm multiplying a decimal times a decimal power of 10. So should I get smaller? Absolutely. So look at this. Use place value concepts again. Every time you multiply by 1/10, notice how they give us the fraction version and the decimal version. Each digit in the number shifts one position to the right. So, friends, do you see how it's opposite from whole number power of 10 to decimal power of 10? We're seeing some differences here. Awesome sauce. Now, let's put it into action. We obviously know that 9 and 2/10 times 1 is going to give me 9 and 2/10 because guess what? What math property says so? I'll wait. Oh, yeah. Multiplication property of 1 says so. Great job. Now let's look at this one. If I go 9 and 2/10 times 1/10, now remember, friends, 1/10 also has that 1/10 fraction version. And how many zeros do you see on that fraction, that denominator? 1. So guess what you're going to do? You're going to move one position of place value to the right. But you know what that does for the decimal? It moves the decimal. Look at the arrow. It moves your decimal to the left. So, friends, let's pause a second. When I multiply, can you see my multiplication symbol? When I multiply by a whole number power of 10, decimal moves to the right. When I multiply by a decimal power of 10, my decimal moves to the left. I want that to repeat and saturate on your mind. You should be able to sing it like it's a song. Multiply by whole number power of 10, decimal moves to the right. Decimal power of 10, decimal moves to the left. And that's with multiplying. Bingo, bingo. Now look at this. Notice what happened. So that means I moved that decimal 1 to the left, and look what we became. We became smaller. Because would you rather have 9 and let's say $9.20? Oh, that's a bad zero. My apologies. $9.20, or would you rather have 92 cents? Well, give me the $9.20. Obviously, we can tell that when we multiplied by that 1/10, our decimal got smaller. Now, friends, what's going to happen when we multiply by an even smaller power of 10? 100th. Well, guess what? I know that 100th also looks like this as a fraction, doesn't it? And how many zeros do I see on that fraction? 2. So guess how many times you're going to move that decimal to the left? 2 times. Give it a go. See what you can do. Can you move this decimal in 9 and 2/10 2 times to the left? Pause your screen and try it out. Well, guess what, friends? If you unpaused yourself and you're back, notice when I move it 1, 2 times, there's a blank. What do? Well, you're right. I have to put that placeholder 0. Now, I'm sorry it looks a little sloppy, but we can see a great example right here. Okay, so I just became 92 thousandths. So notice this. Notice this pattern, like they said right here. When you multiply by 1/10, the decimal point moves one place to the left. When you multiply by 100th, the decimal point moves two places to the left. What if you multiply by 1,000ths? How many times do you think you'll move to the left? That's right, you'll move 3 times. So, friends, there is a pattern here. There is something that we can use as our little secret and our little trick. But you got to be willing to put it in the noggin. All right, friends, so let's go ahead and let's do show and grow number 1. And then you're going to try some on your own. I want you to do your very best. All right, so I take that back. We're going to do show and grow number 1, and we're going to do show and grow number 2. Here we go. 2 and 51 hundredths times 10 to the 4th. Well, hold up. What type of power of 10 is that? Is that a whole number power of 10, or is that a decimal power of 10? Well, if you said whole number power of 10, you are right. Keep that in mind here. So what do I do here? Well, I start with my original decimal. Now, friends, here's the trick to help you out. Rewrite the decimal below so you have all the space to move and groove and fill in as needed. When you try to move and groove up here, you're going to run into the rest of the stuff. That's going to mess you up. I'm sorry if you can hear Ray Ray in the background. Back to it now. I suggest that you rewrite the decimal you're starting with. So when I rewrite it, notice what I'm multiplying by. We said whole number power 10, but what type? 10 to the 4th. So friends, how many times am I going to move that decimal? 4 times. In which way am I going to go? Because that's even more important. If you said I'm going to move to the right, then you are right. Because guess what? You're multiplying by a whole number power of 10. Decimal moves to the right. I should get bigger. So I'm going to move 4 times. 1, 2, 3, 4, and I'm going to plop my new one. And guess what I'm going to do here? I'm going to fill in with zeros. Well, look at this. All those digits are on the left-hand side of a decimal point. That means that this is a whole number. So, friends, when I rewrite my digits here on my answer spot, I need to make sure I don't need any what? Good. If you said commas, then you're on to something here. This reads 25,100, so I need a comma here. Now, here's your mathematician check. You go and say, okay, I had a decimal, and I multiplied it by a whole number power 10. I should have gotten bigger. Did we get bigger? Absolutely. Our product is larger than what we started with. Great job. Now, let's move to number 2. What are you seeing that looks a little different here? Well, I'm starting with the decimal, but I'm multiplying by a decimal power of 10. If I multiply by a decimal power of 10, decimal moves to the left. So friends, look at this. Remember our rule. Start by rewriting the decimal you are originally starting with, 7/10. I see I'm multiplying by 100th. Well, the rule set up here, when you multiply by 100th, the decimal point moves 2 times to the left. So I'm going to take that decimal and I'm going to go 1, 2, and plop. And guess what I'm going to fill in the blank spot? A 0 placeholder. Now, friends, look at this. I recommend rewrite exactly what you just created in a better fashion with no swoop-de-doops beside it. I can really see what I just created. Where are all my digits? They're on the right-hand side of the decimal point. So you know what this is? This is actually a decimal, and this reads 7 thousandths. Now, friends, over here, if we multiplied by a whole number power 10, notice how we said we were supposed to get bigger? So as a mathematician, you can check yourself over here and say, well, I multiplied my decimal by a decimal power of 10. Should I have gotten smaller? Absolutely. Is 7 thousandths smaller than 700ths? Well, guess what? If you want to compare them, you know how to compare decimals. You line those bad boys up and you write your other decimal in. And guess what? Is 7 thousandths smaller than 700ths? Absolutely. Friends, I hope that you're gaining a lot out of today. I know that I'm not with you, but I hope that you have not rushed yourself through this video. And those that have, I will know. I will know. It will let me know that you just skip. So please make sure right now, as you're working on your practice, you can see in the Google Classroom what we're working on. Please make sure you are practicing by doing your work on your paper. I will be checking when I return. I'm excited to see what you have learned today and this new knowledge. Please help your peers. If there's somebody out there who's like, I'm getting this, this is so good, I'm feeling really confident with this skill, help your peers who may need that extra push. Okay, we are a team, and because your ringleader is not with you today, you need to be a team player and help your peers as needed. I want to get a great report back, and I'm excited for what you're going to show me that you know when I return. Love you guys, and I will see you in your next lesson.